We're told that the switch moves from position A to position B at t is equal to 0. We are also given that IDC is equal to 5 amps, and the Laplace transform of our I naught t is I naught s, and then we have the following equation. Now we need to use the initial value theorem and the final value theorem. Both can be found more in the notes linked below the like button, section 12.9, and we need to use these to solve for our A and B. So looking at this problem, well, we know that we're going to be solving for this I naught here. We're going to use the initial value theorem first, and we need to first check C, that the ft contains no impulses, all poles of f of t lie in the left-hand plane, and a non-repeated pole, first order of f of t, may exist at the origin. If that does, we can use these formulas, and now let's use them. So we start off with the limit of f of t, well, t is approaching 0 from the positive, and we get that from here. We're setting this equal to the limit of s is approaching infinity, and then we have s times our f of s. So now we would just plug in our f of s. This right here is our f of s. So plugging this in, we're going to have our IDC, which is 5. We're going to have our s in here, plus our 1 over our RC, and this is being divided by the s squared plus s times 1 over RC plus 1 over LC. Now, we know that s is infinity, and we can't divide infinity over infinity. There's a special rule for that, but instead of using that special rule, what we're going to do is we're just going to multiply everything by 1 over s squared. Now, if we do this, we are going to get that our limit as s approaches infinity is 5 times bracket. We're going to have a 1 first here because we're dividing this by s squared, plus 1 divided by s squared RC, and then closing bracket. We're going to divide this by 1 plus 1 over RCS plus 1 over s squared LC. Now we know that this part, and this part all have infinities in the denominator. And if we have any small number, any constant number divided by infinity, we know it's going to be 0. There's the rule that 1 over infinity is equal to 0. So this is 0, this is 0, and this is 0. That means our answer for here is 5. And so the answer for our part A is going to be 5 amps. Now let's look at B. We need to use the final value theorem to find the value of I naught as t approaches infinity. So we will plug this in, the limit as t approaches infinity. F of t is equal to the limit of s times our function, and remember s is equal to 0. So we're just going to rewrite our equation again. We are not able to do the same thing, because if we were to do the same thing, we would be dividing by 0 a lot, and that would be a lot of rule breaking, which we cannot do. So how do we solve this? Well, for starters, we could just plug in 0. We're not going to be dividing by 0 because although this is a 0 and this is a 0, this 1 over LC is not equal to 0, so we can still divide by this. However, our numerator is going to be 0, and that's because out here is 0. So this is 0 divided by 1 divided by LC. If we have 0 over anything, it's going to equal 0, and so that means our answer for part B is 0, and that is the theory of this problem and how you would go about solving for it.